Think of a cloud. You look up, and you see something soft, white, and seemingly harmless. It looks like a bit of fluff, light, airy, and peaceful, like the steam curling off your morning coffee. But here's the thing. Everything we've been told about the sky is a bit of a trick. That cloud isn't light at all. It's a mountain. It's a massive, heavy mountain of water that weighs as much as 100 elephants, and it's just floating there, hanging directly over your head. The math behind it is mind-blowing. An average cloud, one of those fluffy ones that look like cotton balls, holds about 500 tons of water. If that weight suddenly decided to drop all at once, we wouldn't just call it rain. It would be a disaster. So, it makes you wonder, why doesn't it just come crashing down? Why is a million-pound lake able to just hang out in the thin air, basically ignoring the laws of gravity? The secret isn't really the cloud itself. It's the air. The cloud isn't a solid thing. It's just billions of tiny microscopic water droplets and ice crystals all huddled together. Gravity is constantly trying to pull them down, but there's this invisible force underneath rising currents of air that's pushing them back up. It's like a never-ending tug of war. We're living underneath this giant, invisible engine. The cloud is always technically falling, but it never hits the ground because the wind is there to catch it. It's a perfect, tense standoff between the Earth's pull and the sky's lift. And the weirdest part? It's not even staying the same. It's constantly changing. Droplets are evaporating on the edges and forming again in the middle. The cloud you're looking at isn't a permanent object. It's more like a living, breathing thing. It's constantly dying and being reborn. It's the physical version of a chaotic process that never stops. If you really stop to think about the scale of this, it's wild. Beneath every cloud, there are these huge, invisible pillars of warm air acting like beams, holding up the weight of a skyscraper made of liquid. These pillars are powered by the sun hitting the ground, warming up the air, and sending it shooting upward. You're walking around in an atmosphere that's basically a high-stakes construction project, one that's constantly building itself up and tearing itself down every single second. There is something truly beautiful about how it all works. If we could actually see weight the way we see color, the sky wouldn't look like a clear blue empty space. It would look like a crowded, shifting landscape filled with heavy, liquid giants floating above us. We usually just treat the sky as a nice backdrop, but in reality, it's a non-stop, aggressive exchange of energy. Even when the sky looks clear, the potential is still there. Every bit of air around you is holding moisture, waiting for the right moment, a little drop in temperature, or a shift in pressure to turn into something you can see. When that balance shifts, the water has no choice but to clump together. It turns from invisible gas into a heavy, real-world force. It's all incredibly fragile. There's this process where the tiny droplets bump into each other, merge, and get heavier. Once they get too big, the air can't hold them up anymore. The deal between the wind and the water is broken, and gravity finally gets its way. Rain isn't just a gift from the sky. It's the moment that whole complex system gives up. We stand under these clouds, holding all that weight, and we just call it a rainy day. But really, we're witnessing a battle. The next time you look up, try not to see the fluff. Try to imagine the mountains hovering above you and realize how delicate the balance is between you and the weight of the sky. The atmosphere isn't a soft blanket. It's a battlefield. Every drop that hits your skin is a moment where the atmosphere lost the fight, and the weight of the world finally came crashing down to meet the Earth. It's a quiet reminder that we're living on a planet ruled by huge, invisible forces, and we're all just guests hanging out beneath the massive weight of the air above us.